If the galaxy is so vast, why is the sky so quiet? And why would finding alien microbes be the worst news we could ever receive? Let's start small. Hold up a single drop of pond water to the light. Inside that tiny liquid world, life swims, bumps, eats, and divides. In its own way, it feels crowded, ancient, and complete. Now pull back in your mind, far past the trees and the town, past the silent curve of the Earth and the orbit of the moon, out into a city of stars. Our Milky Way galaxy holds hundreds of billions of suns, and we now know that planets are not the exception, but the rule. Billions of them are likely warm, rocky, and circling their stars at just the right distance for liquid water to pool on their surfaces. Yet in all this staggering immensity, we have no confirmed neighbors, no clear repeating signal, no colossal works of engineering lighting up the dark, just a profound cosmic silence. In 1950, over a casual lunch, the physicist Enrico Fermi was joking with his colleagues about UFOs. He paused, did a quick calculation in his head, and then asked a simple, heavy question that has echoed ever since. Where is everybody? His question cuts to the heart of a paradox. Our galaxy has been turning for over 13 billion years. That is long enough for almost anything to happen. Long enough for life to arise, look up, and begin to travel. Because once a species can cross the space between stars, even slowly, the galaxy becomes small. Time shrinks distance. A journey at just 10% of light speed could cross the entire 100,000 light-year disk of the Milky Way in a million years. Imagine a civilization builds small, self-replicating probes. They arrive in a new star system, spend 1,000 years using local material to build two copies of themselves, and then send those copies onward. A slow, patient wave of exploration. Even with these conservative numbers, that wave would wash across the entire galaxy in 10 to 100 million years, a geological blink. If the whole of galactic history were a single calendar year, this journey would take less than 3 days. So if anyone, anywhere had started this journey when the dinosaurs vanished here, their probes should have arrived by now. We should see their lights, but the night is still. The emptiness is loud. This silence is the Fermi Paradox, and the great filter is one way to make sense of it. The idea is simple. Somewhere on the long road between a dead planet and a star-spanning civilization, there is a barrier. A test so difficult that almost nothing gets through. This barrier might be one single, impossibly high wall, or it could be a long, dark gauntlet of many trials. Perhaps the filter is behind us. Perhaps the jump from non-living chemistry to the first cells so fantastically improbable it has only happened once, here. Or maybe the leap from a simple microbe to a complex animal with a nervous system is the true bottleneck. After all, life on Earth remains single-celled for nearly 3 billion years. A quiet ocean with no one to see it. Or maybe the filter is still ahead of us. This is the more chilling thought. Perhaps intelligence itself is the trap. When we look to the sky for answers, the silence deepens. We have searched for the waste heat that vast civilizations would produce. The WISE infrared telescope scanned 100,000 other galaxies. None of them glowed with the excess heat expected from a society harnessing most of its starlight. This doesn't rule out efficient, quiet civilizations, but it means galaxy-spanning empires, if they exist, are very good at hiding. We chase down anomalies. Tabby's star dimmed in bizarre, unnatural ways, sparking whispers of alien megastructures. But years of follow-up work pointed to a simpler, if messier, explanation. A vast, irregular cloud of cosmic dust. The mirage faded, as they so often do. And we listen. Projects like Breakthrough Listen have aimed giant radio dishes at thousands of nearby stars, waiting for a whisper of technology. So far, nothing has been confirmed. Intriguing candidates appear, like a signal from the direction of Proxima Centauri, only to be traced back to our own earthly interference. With each null result, the sky feels a little more empty. Perhaps the universe itself is the filter. It is not a gentle cradle, but an active and sometimes violent place. A massive star dying nearby can go supernova. In its final brilliant moments, it would outshine the entire galaxy, flooding a world like ours with radiation that could shred its protective ozone layer. Life on the surface would be scoured. These events are rare, but over billions of years, rarity becomes inevitable. Then there are gamma ray bursts, the focused death beams of collapsing stars. If one were aimed at us, even from thousands of light years away, it could sterilize the sunlit side of our planet in a flash of terrible light. These cosmic pruning shears might ensure that very few biospheres get the long, uninterrupted peace needed for intelligence to bloom. Even without cosmic intervention, life is fragile. Our own planet carries the scars of at least 48 great mass extinctions. The one at the end of the Permian period, about 252 million years ago, came perilously close to wiping the slate clean. Life always climbed back, but each time the clock of complexity was reset. Our own timeline is perhaps the most important clue. Life seems to have appeared early on Earth, with signs dating back almost 4 billion years. But for most of that time, it was just microbes. Complex, multicellular life only exploded into existence about 540 million years ago. Modern humans are a mere 300,000 years old, and our radio technology is just over a century old, a single tick on the geologic clock. The long, quiet stretches are telling. Some doors take ages to find, let alone open. This brings us to the most profound, unsettling part of this story. Why finding simple life on Mars could be the worst news in human history. The philosopher Nick Bostrom framed the chilling logic. Right now, we can hope the great filter is behind us. We can hope the emergence of life itself is so rare that we are one of the first in the galaxy. The silent sky would then be an empty stage, an invitation. But if we dig into that Martian soil and find microbes that arose independently from life on Earth, that hope shatters. It would mean the first step is easy. It happens wherever conditions are right. And if the universe is filled with simple life, but empty of intelligence, that implies the filter is not in our past. It must be in our future. A wall waiting for every fledgling civilization, somewhere between microbes and starships. That beautiful discovery would also sound an alarm for all of humanity. But there are gentler possibilities. Perhaps the silence is not an omen, but just a matter of timing. Perhaps we are simply early. Our sun is a bright, relatively short-lived star. The vast majority of stars are small, dim, red dwarfs. They will burn not for billions of years, but for trillions. The universe is still in its infancy. The era of stars has only just begun. It's possible that the great galactic civilization isn't in our past. It's in the unimaginably distant future. We are not late to a silent party. We are the first to arrive. Or perhaps advanced civilizations make a choice. They might become so efficient that they produce almost no waste heat. They might abandon loud, messy radio and communicate in ways we can't detect. Or they might look out at the vast, dark, and potentially dangerous universe and decide the wisest thing to do is stay quiet, to not draw attention. The silence in that case would be a sign of intelligence, not its absence. In the end, we are left looking at ourselves. Our own tools could be the final test, the bridge across the filter, or the thing that ensures we never leave home. Back to that drop of water. Inside it, 4 billion years of luck are stacked one on top of the other. In us, that long chain of luck has woken up, and it is looking at the stars. The great silent sky could be a tombstone, or it could be an invitation. Our choices will decide which story is true. The next chapter for the Milky Way could be just as silent as the last. Or it could hold our footprints, faint at first, then spreading. We are small. We are perhaps very early. And for now, we are here. The quiet doesn't give us an answer. It gives us the choice. Thanks for watching.